Hello students and welcome to Chemistry B. I'm Miss Slate and today we're going to talk about neutralization and titration reactions. So first off, we've talked a little bit about acids and bases and indicators. A neutral substance has a pH of 7. Acids have a pH lower than 7 and bases have a pH greater than 7. Indicators like litmus paper or a universal indicator like shown here indicate the pH based on the color of the substance. Neutralization is the process of an acid reacting with a base. And acids and bases are always going to react to produce water and a salt. It's essentially a double replacement reaction where one of the products is water. So, for example, the hydrogen will replace the sodium in sodium hydroxide, and vice versa. So double replacement, the ions change places. So in this one, hydrogen and hydroxide are going to combine together to form liquid water. And sodium and bromide will combine to form the salt sodium bromide. So again, neutralization reactions are one in which an acid and base react together to produce ionic salt and water. And when we're talking about the salt produced in a neutralization reaction, we're talking about an ionic compound made up of the cation from the base and the anion from the acid. So again, neutralization is essentially a double replacement reaction where one of the products is water. So acid-base titration is a method for determining the concentration of a solution by reacting it with a known volume of a solution with a known concentration. And we're going to be doing this in the lab in the next couple of days. So you have it set up like they have before. You have these two glass tubes that are burettes. Burettes are special because they are graduated in such a way to show us how much liquid is dispensed from the burette. So the numbering is going to be inversed on them. So the acid is going to be in one burette, the base is going to be in another, and then you're going to have an Erlenmeyer flask that also has some kind of indicator in it. So one of the burettes is going to have a solution of unknown concentration, and the other contains a solution of a known concentration. The solution of known concentration is referred to as the standard solution. And it doesn't matter which one is which. You can have the standard solution be the acid, or you can have the standard solution be the base. Okay, so what you're going to do is you're going to dispense a certain amount of the standard solution into the Erlenmeyer flask, and you're going to record that, okay? So for example, if the acid is our standard solution, we're going to write down the known concentration and molarity of the acid, and we're going to write down how much that we dispensed out of the burette, let's say like 50 milliliters or something. Then we're going to add very slowly base from its burette until we see our indicator in the flask change color. Once the indicator changes color, that means that the number of moles of hydrogen ions from the acid is equal to the number of moles of hydroxide ions from the base. This is known as the equivalence point, okay? And this is where we want to stop our titration. Because if we stop our titration exactly at the equivalence point, we can then use the molarity equations and some basic stoichiometry to determine what the concentration of the unknown solution is. So there are many different acid-base indicators, as you can see here from this chart, and they change color at slightly different pHs. The universal indicator at the bottom is called universal because it has a color for every pH. And you would select different acid-base indicators depending on exactly what kind of reaction you're doing and what kind of initial pH you're starting with. We're going to be working in the lab with phenolphthalein here, which goes from colorless to pink. Let's look at an example of a titration calculation. So this question says, by titration, 20 milliliters of strontium hydroxide is neutralized by 25 milliliters of 0.05 molar hydrochloric acid. Find the original concentration of the strontium hydroxide. Anytime we're doing a titration equation, the very first thing we must do is write a balanced chemical equation for the reaction. So in this case, hydrochloric acid, HCl, is reacting with strontium hydroxide, SrOH2. The products are going to be water and strontium chloride, and then we balance it by putting a coefficient of 2 in front of hydrochloric acid and water. The next thing we're going to do is we are going to use the equation for molarity and the volume of strontium hydroxide to figure out, and the volume of hydrochloric acid to figure out how many moles of HCl are present in the solution. Once we know how many moles of HCl are present in the solution, we can use stoichiometry to convert that to moles of strontium hydroxide. So I took my 25 milliliters of hydrochloric acid. I converted it to liters of hydrochloric acid by dividing by 1,000. Then I multiplied it by molarity. Remember, molarity is just moles over liters. So if the concentration is 0.05 molar for hydrochloric acid, that means 0.05 moles of HCl over 1 liter. Now my liters have canceled, and I'm left with just moles of HCl. Then I'll multiply by our mole ratio, which is 1 mole of strontium hydroxide to 2 moles of HCl, and that gives me 6.25 times 10 to the negative 4th moles of strontium hydroxide. Now that I know how many moles of the base are present, I can just divide by liters of the base that was added to determine the molarity. So my 6.25 times 10 to the negative 4th moles divided by 0.02 liters, because I just converted milliliters to liters, and we get a concentration for the base of 0.0313 molar. So the balanced chemical equation is required in this case because we need the stoichiometric coefficients to convert between moles of acid and moles of base. You can't assume that it's always going to be 1-to-1. So a good plan is to start with the volume of whichever substance that you know the concentration of. And then you can use the molarity as a conversion factor between volume and moles of that substance, and then use your mole ratio from the balanced chemical equation. And that's all we need to know for neutralization and titration.